Hello everyone. As I discussed in my last video that we are going to solve a question related to Coulomb's law and the force acting between the charges. Now the situation is there are two charges and on the axis of their two charges there is a midpoint, and somewhere above that midpoint there is another point P where we have kept a point charge, and on that point charge the two charges are applying force. And what would be the magnitude of force and what would be the direction of force we are going to see in this question. So to begin with this question, first of all, as I'm doing in all the videos, I'm writing the Coulomb's law because we are going to use this formula. And I'm intentionally writing this so that after watching it 2 to 3 times, you remember it by heart. So F is equal to K Q1 Q2 by R square. Sometimes you can write Q1 as a small letter or capital letter, that doesn't matter. But you should know that these two are the charges. And K is equal to 9 into 10 power 9 Newton meter square Coulomb power minus 2. So let's come to the question, and here are the two charges. One is positive and the other one I'm taking negative, and they are kept at the distance of, let's say, 2 centimeter from each other. And what I'm trying to do is I'm trying to make an equilateral triangle here, and this is also 2 centimeter, this is also 2 centimeter, and this is the midpoint of the two charges. The axis of the two charges, there is a midpoint, and above this point is this vertex of this equilateral triangle. And at this point we have kept a point charge of, let's say, 2 microcoulomb. And these two charges, plus and minus, they are also having the magnitude of, let's say, 2 microcoulomb and 2 microcoulomb. 2 microcoulomb. So the first question is, what would be the direction of force? And the direction of force I have already explained to you in the last video. In this video, I'm going to calculate the magnitude of force. So because this is positive and this one is also positive, so the direction of force would be upward at an angle, not directly vertically upward, but it will point upward at some angle. And that angle exactly would be 60 degree from the horizontal, because this line, the one side of this equilateral triangle is at 60 degree with base. The direction of force at this 2 microcoulomb charge, which is kept at the vertex on the top, would be towards the negative charge because of the attractive force. This charge is positive, this charge is negative. So the resultant force would point towards this side. If you use the law of parallelogram, you can easily find the direction. And if you don't know how to do that, you can watch the last videos. So now the question is how to calculate the magnitude of this force. So what we can do is we can divide this question into 2 to 3 steps. So the first one, let me write few points here. Let's say this is point A, this is point B, and this is point P. So what we have to calculate is we have to first calculate the force at point P due to charge at point A. Then we will calculate force at point A as force at point P due to charge at point B. Then we will add the two forces. Of course, we are going to consider the vector addition, and we will see when we are doing that. So let's calculate the force at point P due to the charge at point A. So FPA is equal to K Q1 Q2 by R square. And I'm not going to write that formula again. You can see here the formula. And K is 9 into 10 power 9. So 9 into 10 power 9. And I'm not writing unit. 2 microcoulomb. 2 microcoulomb means 2 into 10 power minus 6 coulomb. And here also 2 microcoulomb. So 2 into 10 power minus 6 coulomb again, divided by the distance between A and P is 2 centimeter, and I will convert centimeter into meter, so it will become 2 into 10 power minus 2 square, because the distance is squared in Coulomb's law. So 2 into 10 power minus 2 square. If we will solve it, we will get FPA is equal to 9 into 10 power 9, 2 here, and this 2 is squared, it becomes 4, so they can cancel. Now what is left with us is 9 into 10 power 9, 10 power minus 6, and another 10 power minus 6, and here 10 power minus 2 squared, so it becomes 10 power minus 4. So I can write here 9 into 10 power 9, 10 power minus 6, 10 power minus 6. If we will add all, we will get 10 power minus 3. And divided by 10 power minus 4. And if 10 power minus 4 comes up, so 10, it becomes 10 power minus 10 power plus 4. 10 power plus 4 gets added with 10 power minus 3. So what we are going to get is, we are going to get 9 into 10, and it's a 10 power just 1. So we can write FPA is equal to 90 Newton. FPA is equal to 90 Newton. If you do not want to do the same calculation again, if you will see carefully, this is 2 microcoulomb charge, this is 2 microcoulomb charge. It means FPB is also going to be 90 Newton. The only thing is the direction would be towards the point B. So I can write here FPB is equal to 90 Newton. So force at point P due to point B is 90 Newton. Now, what would be the direction of force and what would be the magnitude of force? So the direction of force is towards the right side, and the magnitude of force we can find by adding these two vectors. And if we are going to take the magnitude of the vectors, and to find the magnitude we need to know the angle. So what we can do here, this is 60 degree, this is 60 degree. From the horizontal, if this is the 60 degree, so this is going to be 60 degree because vertically opposite angles. And this is 60 degree from the horizontal, so this is also going to be 60 degree. Now, this FPA is at 60 degree with the horizontal, and FPB is also at 60 degree with the horizontal. So what we can do is we can find the component of the forces. So component of FPA, one component will be vertical and the another one would be horizontal. So the horizontal one, because it's adjacent to the angle, we can write FPA cos theta, and this one would be FPA sin theta, the vertical one. Similarly, for FPB, one component would be vertically down and the another component will be towards the right side. The one which is right side, it's adjacent to the angle, so we can write FPB cos theta, and here FPB sin theta. Now if you will see carefully, FPA sin theta and FPB sin theta, they are cancelling each other. So the situation looks something like this. FPA and FPB, they are cancelling each other. So their effect is 0. But FP, and I should make a correction here. FPA so if we draw the two components here, FPA sin theta and FPB sin theta, what we can see is they both are cancelling each other. But FPA cos theta and FPB cos theta, they are pointing towards the right side in same direction, something like this. So these two vectors, they will get added. So FPA cos 60 degree and FPB cos 60 degree, they will get added. So the F net at point P, F net at point P would be FPA cos 60 degree plus FPB cos 60 degree. And we know FPA and FPB, they have same magnitude. So we can write F net is equal to 2 into, because everything is very similar. FPA is 90, FPB is 90, cos 60 and cos 60 there. So here I can write 2 FPA cos 60 degree, and F net would be 2 into 90 into cos 60 is 1 by 2. So this gets cancelled and we get F net is equal to 90. F net is equal to 90 Newton. And the direction of force would be towards the right side with a magnitude of 90 Newton.